All right, usually when we start out doing trig identities, we usually start with simplifying expressions. And in some cases, simplifying expressions could be a little more difficult than the actual proofs because you don't know what you're trying to get to. So you don't know what it equals and when to stop sometimes. So let's look at the first one here. We have cotangent theta times sine theta. So one thing that I try to look for is, do we have any squareds in there? If we have squareds in the problem, we're probably going to be using either some type of Pythagorean identity or a version of it, or some type of factoring. In this case here, I don't see any, so what I would do in this case is just convert things to sine and cosine, and I can see that the cotangent, I know from the cotangent identity, is cosine theta divided by sine theta, and we're multiplying it by sine theta, and we know sine theta divided by sine theta is 1. So we would get cosine theta for this answer. And when do I know that I'm going to stop? Well, is there anything else we can do with cosine theta? So there's nothing we can simplify with that, so we are done. All right, so in the next one, I have 1 minus sine squared theta. I see the squareds in it, so I'm automatically thinking that's some type of factoring or Pythagorean identity problem. And some students miss this, but the 1 minus sine squared theta, that is actually the Pythagorean identity solved for the cosine squared. So in this case here, the top would be cosine squared theta divided by sine squared theta. And we know from the cotangent identity that the cosine theta over the sine theta, we're going to square that. That's the same thing as the quantity squared. And we know cosine theta over sine theta is equal to cotangent squared theta. And we would stop at that point right there. Now, some students might not know when to stop it here. Like, what can I do something else with this? And they might go back in and try to sub in a Pythagorean identity. Well, that wouldn't be making it any simpler. That would actually be making it more complex. So that is one clue on when you need to stop with this. Okay? Hope that helps for the first set. In this next example, we have sine theta times cosecant theta divided by the cotangent of theta. Well, if we look at the numerator, there's a cosecant theta, which is the same thing as 1 over the sine of theta divided by cotangent theta. Well, that simplifies to 1. So we have 1 over the cotangent of theta, which is the reciprocal, is the tangent of theta, reciprocal identity for the tangent. You could have also recognized, if you missed this, that cotangent is cosine theta divided by sine theta, and if you multiply by the reciprocal, you get sine theta over cosine theta, which is also the tangent. All right, now that we've done some examples where we simplified expressions, let's do our first proof here. So we're now going to add an equation to this, and what we want to do is we want to prove that one side is equal to the other. And when we do this, what we want to do is work with one side at a time. You're allowed to work with the left side or the right side or both sides to break them down. But what you can't do is you cannot use properties of equality. So in other words, you can't add to both sides, subtract. You can't take the cross products. You have to work with the sides separately. And just like the tips with simplifying expressions, we want to look for powers here. So I see a squared, so I can use Pythagorean identities. I can try to find some type of factoring, or I can do both here. In this case here, I see they have a cosecant squared in common. And obviously, the left side looks more complicated than the right side. So I'm going to work with the left side. So I'm going to say cosecant squared theta. I'm going to factor that out, which would be 1 minus cosine squared theta equals 1. All right, so again, my target is I want to get to 1. So we look inside the parentheses here. We have 1 minus cosine squared. Well, that's equal to the sine squared. So I'm going to replace that by sine squared theta. All right. Well, cosecant squared theta is equal to 1 over sine squared theta times my sine squared theta. And then we can see that simplifies to 1, and we are done. We've proven that the left side equals the right. All right, so here's another tip when you're proving trig identities. So we can see we have two fractions, sine over cosine plus cosine over sine. The left side looks more complicated, and a lot of times when you're dealing with separate fractions, the tip is you want to get a common denominator. All right, so in this case here, the common denominator would be on the left would be cosine theta times sine theta. All right, so when you create a new numerator, the cosine theta would divide into the denominator, leave you with sine. We would have to multiply it by the sine that's already up top, so we get sine squared. Converting the next fraction, sine theta divides into cosine theta, sine theta leaves you with cosine to multiply by the top. So we get cosine squared theta. Well, from the Pythagorean identity, what does sine squared theta plus cosine squared theta equal? Well, that equals 1. So we now have the left side is equal to the right side. So common denominator is another trick and tip if you're dealing with fractions in the problem. All right, in my last example here, we're going to work with the left side. And if you look up top, the sine squared theta minus 2 sine theta plus 1, that follows the pattern of a quadratic. So this is really like we were factoring, let's say, x squared minus 2x plus 1. Well, how would that factor? Well, that would be x minus 1 times x minus 1. So the numerator in this case would be sine theta minus 1 times sine theta minus 1. So if you multiplied that out, you would get sine squared theta minus 2 sine theta plus 1. All right, well, that works out nice because the denominator is sine theta minus 1. And then we have the same grouping up here, so that divides out. So we have sine theta minus 1 is equal to the right side, sine theta minus 1. And we're done. All right, I hope that helps get you started with proving trig identities. Please like and subscribe. Thank you.